Hey everyone, can everybody at the back hear me? Awesome, okay. So I'm Nourhan Khaled, and today I'll be talking to you about GitOps, my favorite ops of them all. So before we begin, just a bit of background by myself. So the clicker's not working. I'm a computer science graduate from the German University in Cairo. My bachelor thesis was kind of at the intersection of reinforcement learning and robotics, which got me really interested in machine learning. And so when I graduated, I joined Synapse Analytics, which is a data science and AI company based in Egypt. So I joined as a machine learning engineer, and after a while, I found myself kind of interested in like the bigger scope of things. I didn't want to be like siloed in just a particular point, and so I transitioned into DevOps in 2020, and a lot of interesting things started happening from there. So I've taken part in the company's adoption of Kubernetes, taking part of the migration to infrastructure of code as we were scaling, and of course, the adoption of GitOps, which is what I'll be talking to you about today. Okay, so today I'll be walking through just like what is GitOps, and then comparing it to the standard CI/CD workflow, and then I'll be talking a bit about the benefits of GitOps, why we should use it, and then I'll talk about the concrete example of Flux v2, which is an implementation of GitOps for Kubernetes, showing you a quick demo and a final recap. So, a lot of the times when I was doing DevOps, whatever that means, it kind of felt a lot like this. So on one hand, we have a bunch of frameworks and a bunch of tools, and on the other hand, we have our application requirements and our delivery requirements. And it's not always the case that these tools kind of are made for these requirements or these specifications, but we somehow always make it work. And it's not always the most elegant of solutions, but it works anyway. And I do distinctly remember like 2 distinct instances where it felt kind of the opposite of this, and that was my introduction to infrastructure as code. It felt kind of clean, kind of elegant as companies were scaling. And actually, this picture was taken from the talk by HashiCorp, which introduced me to Terraform. And the other instance where DevOps kind of felt like much the opposite of this was my introduction to GitOps. And actually, Kelsey Hightower, when I was doing the research to the talk, I saw that Kelsey Hightower spoke very highly of this framework. And he said that GitOps is the best thing since configuration as code. And so what is GitOps? What is this new ops player in the field? Why do we need just another term over there? So personally, I'm not really big on like formal definitions because I tend to find that these definitions also need like further definitions themselves. So the thing that kind of made sense for me was that GitOps is a framework. It's a framework in which deployments, changes, and everything is basically done through Git. And I highlight framework here because GitOps is not a specific tool that you should use. It's basically a framework made of a bunch of principles. If you implement those principles, you're doing GitOps. If you're not, then you're not. GitOps is basically CD for cloud-native applications. And then there's the question of what is infrastructure as code versus GitOps. And actually, Justin over here had a Twitter space over a couple of weeks ago that kind of addressed this question, and it might give people the impression that like infrastructure as code versus GitOps, they're kind of alternatives, but they're not. I think something that I heard in this Twitter space that really made sense to me was that you can think of infrastructure as code as like the description of your system, and GitOps is the execution. How do you reach that state of the system? And is GitOps only for Kubernetes? As I said, it's a framework. So if you implement the principles of the framework, no matter what infrastructure you have underneath, then you're implementing basically GitOps. And so let's get to the 4 principles of GitOps. The first of which being that the entire system is described declaratively as code. So what does declarative mean? So declarative basically means that your system is described as a set of facts as opposed to a set of instructions. So for example, if we have an application or some code that says, an imperative paradigm would say, I need this OS deployed on this machine, and I want you to go to this URL, fetch those dependencies, and then cd to this directory, copy a bunch of code, and then go ahead and do that 3 times on 3 different machines. The declarative alternative would be, I have this OS on 3 different machines, and I need the dependencies from this URL, and that's it. I just define what I want as opposed to how I want to do it, And fortunately for us, Kubernetes is already declarative, so we can define things like, I want this version of the backend deployed on this node, and I want 3 replicas with these resources, for example. So we already have Kubernetes as a declarative system. And the second principle states that basically the desired system is versioned in Git. So this is like the Git in GitOps. And what this principle states is that if you want to know the state of your system at any point, just look at the repository. Because by enforcing this principle, you basically solve like the single source of truth conundrum. You no longer have one thing on your cluster and another thing defined in your repository. You basically unify everything and make Git like that source of truth. And kind of to enforce this principle is the third one, which says that we automatically apply approved changes to the cluster. So this is done by means of a software agent running on the cluster that is constantly pulling in that desired state from the repository. And finally, something that I find is kind of like the edge of GitOps. Oh, there's a party over there. OK, anyway. Something that I find like the edge of GitOps is the drift consolidation. So drift consolidation is basically if you have, for any reason, a change between the state of your cluster and the state of your repository, then this software agent kind of kicks in and reconciles this change and brings it back to the desired state defined in the repository. And this is where GitOps comes in with kind of like the pull-based side of things, as opposed to like the push-based model we used to have. So actually, let's get to comparing it with the standard CI/CD. The standard CI/CD workflow is basically a push-based model. So what we usually have is we have our developer writing out some application configuration manifests, pushing that to Git, and that push kind of triggers some CI/CD pipeline to run. Maybe your CI has things like linting, security checks, and then the CD part is basically you're giving your CI server full access to your cluster, and then it will pull those manifests and apply them to the cluster. Something also worth noting here is a lot of Kubernetes application developers work with Helm, so we all rely on things like Prometheus, a lot of stacks like Loki, Grafana, a lot of things we use already prepackaged charts with Helm. And so in this workflow, we don't really have something very specific with Helm. So some people might go by where they like just SSH into the server, and they basically just run the commands Helm add repo, Helm install the release. Others might have that written in the script, and the script is basically also like executed in the CI server. So that's something to keep in mind. GitOps, on the other hand, so as you can see, we kind of removed that connection between the CI server and the cluster. And actually, don't be fooled here. I put Flux, which is like the software agent. It's outside the cluster, but it's actually inside. I just did that for visual purposes. But the software agent basically pulls the state from the repository and then applies it on the cluster. You no longer have to give your CI server that full access into the cluster.
I wasn't computer science.
And so why do we need GitOps? Why the new framework? Why do we need something else in the stack? We already have a lot. Doesn't the standard CI/CD work? Let's see. So hands up if you've ever changed the manifest on the cluster and forgot to commit it. Yeah, a bunch of hands here. So yeah, with GitOps, you basically don't have this because when you're adopting GitOps, you're kind of like changing the mindset of everyone using it to only put changes to Git. So any new changes are put through Git, any edits, any deletes, you basically do everything in Git. So like kind of following up on that, with GitOps, we end up with much easier and quicker error handling and recovery. So actually, I do remember a scenario where we had someone or something delete a namespace from the development cluster, and we had GitOps in place. So we didn't notice at all, except maybe after a couple of weeks. And the only reason we noticed was there was some resource that was not tracked with GitOps, and that resource was kind of a bit crucial for the application to work properly, and that's why we noticed. So GitOps saves lives. In my case, it did save mine. So yeah. As with any CI/CD tool out there, it promises speed. With GitOps, we have faster deployments, and we can do deployments more often. And that's because we remove the friction of having to do another step after post-merging, for example. So basically, you just release your application as soon as you have the code ready. And there is no other like further steps you need to do because the software agents on the cluster are going to make sure that your state is up to date, all the changes you introduced are automatically applied. And then with GitOps, we also end up with self-documenting deployments. So basically, at any point, if you want to know the state of your system, you take a look just at the repository. So I can recall many times people would ask me, which version of this chart do we have deployed in the cluster? Do we have the latest version deployed yet? And with GitOps, I could basically just like give them read access to the repository. They would go in and check out for themselves. And actually, a kind of a cool feature with that self-documenting deployments is that the commit logs the commits kind of act like audit logs. So you can basically find out who did what, when, through just looking at the commit messages of the repository. With GitOps, you also end up with a lot of shared knowledge in the team, so everybody can see, it's kind of like an unexclusive system observability. Everybody can see what's deployed at any time. They can also follow the trail of commit messages to find out how we reached that state, so they can see the fixes, the features, the performance commits, and kind of gather the trail of thoughts that the developer who created the application went with. And finally, we have easier credential management with GitOps, because you no longer have to give your CI server basically God mode privileges to the cluster to access the cluster and apply these manifests. And by extension, you don't have to do that for the developers. If anybody needs to introduce any changes to the application, they would do that through Git. Doing revert on deleting something is just as easy as git revert, and you no longer have to do anything by accessing the cluster directly. You just do it through Git. And so let's actually take a look at Flux. Flux v2 is one of those software agents I spoke about. It's the software agent that runs on the Kubernetes cluster. And this software agent is basically responsible for syncing the state of the cluster with the state of the repository. And it's composed of something called the GitOps toolkit. And the GitOps toolkit is basically like a set of composable APIs that you can use to basically build your own CD pipeline. And that's what Flux used to build Flux. So one of these first components is the source controller. And the source controller is basically responsible for pulling in the artifacts from the sources. And the sources here can be a Git repository, a Helm repository, or a Helm chart. And then we have the customized controller. So the customized controller is basically it's in place of the kubectl apply. So Flux is built, it's very dependent on customize. If you don't know what customize is, you can go ahead and check customize.io. But just to give you a quick brief, it's kind of a template-free way to customize your Kubernetes configurations, meaning that if you have, for example, 3 environments and you have different configurations that are very environment-specific in these 3 different environments, what you can do with customize is basically define a common configuration that applies on all these environments, and then using something called overlays, you define the specific environment-specific configurations, and customize will basically patch these environment-specific configurations to the intended base configuration, and you can end up with a lot of cool features with customize. And also because Flux uses customize, you can harness all of these cool features in your code. And then we have the Helm controller. So this is the question I raised earlier. How do we manage Helm? With Flux, you have a Helm controller where basically the source controller pulls in the Helm repository, and the Helm controller is responsible for the Helm releases, so the deployment of these releases in the cluster. And you can also override the values and define all these in your Helm release. And then we have the notification controller, full observability in your system, events coming in and out of your controllers, and it can integrate with a bunch of plugins like Microsoft Teams, Slack, even generic webhooks. And then these 2 components here are optional, so if you install Flux by default, these are not deployed, but I find them very cool. And let me give you an example of why we might need this. So for example, let's say I have an application, I have a backend application, and I have v1 deployed, and then the development team finished v2. So what I would normally do is I would go to the manifest, change that v1 into v2, push the changes, and it's deployed. And with these 2 components here, the image reflector controller and the image automation controller, you basically don't have to do that anymore. What happens is the image reflector controller basically scans your container registry for new tags or new digests, depending on, for example, some regular expression that you define. And then the image automation controller will basically apply those changes in the manifest. So I no longer have to step in and manually do that. So this is very cool. Oh, it's demo time. So I actually found out that a lot of people had hiccups in their demos because of the internet. So I went on and did the smart thing. I recorded the demo. So what I want to show you in the demo is basically 3 things. So unfortunately, I don't have much time to show you all the cool features of Flux. But I'll be going through the bootstrapping, so installing Flux on your cluster, showing you how easy it is to update a manifest and deploy, for example, a Helm release in the cluster. So on the right here, I have a kind cluster that I just created before the demo. And on the left, I'll be executing the commands on Flux, and this will be directly reflected in the cluster. And so let's start with the Bootstrap command. So the Bootstrap command is basically the command that installs Flux in your cluster. And what that command does is, so it takes in the source. In my case, it's here. It's GitHub. It's a GitHub repository. It's called Flux example. And I want to sync my main branch to my cluster, and so I specify the branch here. And then the path here is basically kind of like the entry point to Flux. So this is where Flux is going to look at first before, as it starts syncing my code to the cluster. And so let's take a look at what's happening here. The first thing is Flux is generating these component manifests. So the manifests that are defining the controllers I spoke about. So the Helm, customized notification, and source controller. And then it's actually installing them on the cluster. So as you can see on the right, we have already the Helm, customized notification, and source controller being installed. And after it generates these components, it can start getting to work. Flux is going to start pulling in whatever was in the repository and deploying it in the cluster. So it goes ahead and generates something called the sync manifest. And the sync manifest is basically like the YAML equivalent of this command, specifying the source and everything I define in this command. And after the sync manifest is generated, it's going to go ahead and apply, like, you can now just go ahead and start syncing everything in the repository to the cluster. So as you can see here, I already have like my app deployed far up. That's just a simple web app that I created. I already had a bunch of Helm releases defined, so Nginx and Prometheus is going to start showing up in just a few seconds. And so this is basically how easy it is to bootstrap a cluster with Flux. Just run this command with Flux installed, and then you're good to go. So let's actually take a look at what that sync manifest looks like. So this is basically like exactly what I had in my command. This is generated by Flux and pushed to my repository. And this is basically the definition of the Git repository. So this is the source. And then this interval here is basically how frequently Flux is going to pull the state of the repository and apply it to the cluster. And then the URL, of course, of my repository here. And then this customization is kind of like telling Flux how to consume the source. So here, this customization is going to go ahead in the path called clusters and staging, is going to start pulling any customization defined there and applying it to the cluster. There's also this flag here called prune, and this basically tells Flux if this manifest is removed from the repository, go ahead and remove the parallel resource in the cluster. And then we have the same interval here, basically how frequently this customization is going to be executed. OK, so let me show you what a definition of a Helm repository would look like. So as opposed to running this command like we would do in the good old days, Helm repo add, and I would add my repository from this URL, you basically define it as the YAML now. So everything is now treated the same. The manifests are the same as Helm repositories, same as releases. And so if I want to deploy a release, now I have the repository in my cluster. If I want to deploy a release, I would go ahead and define a Helm release with this YAML. This is a CRD installed by Flux. And I would reference basically the source of that release. So the source here is the Helm repository that I just defined. And here you can also like define which namespace you want to deploy to. And you can also go ahead and just like below the target namespace, add the values of the chart. So you can do a lot of cool things. And now that we have Helm basically defined as YAML, you no longer do things outside of the Git repository. You just do it. Everything is documented in here. And so right now, let me show you. So this is my app on the right. I have V1 of some simple web app deployed. Let me show you what that looks like. So basically, just a simple web app that displays an image. And so this is V1 of the application. Now I want to update the application. And just to show you how easy it is, let's go ahead and edit the version of the application over here. I will change that to V2. And then I will just add my changes to the repository, add a meaningful commit message, and then push these changes into the repository. And so because my interval in the source controller was very small, so it was basically just like 1 minute, we already have the new version of the application being deployed over here. But on the other hand, if you have, for example, like a larger interval, you can tell Flux to bypass that, like don't wait for the interval and just bypass that and run this command flux reconcile and whatever you want to reconcile to force Flux to start reconciling right away without waiting for the interval. So this is the new YAML. This is here we have v2 deployed just by me pushing the change to Git. It's already on the cluster. And let me just remove that so I can show you what it looks like right now. And so if we go ahead and check our application, let me just refresh. And now we have v2 deployed, just as simple as that. Just change the YAML and push to Git. Everything is done for you. And finally, I want to act as a very tired developer who's going to accidentally delete a namespace. And so I will go ahead and delete the entire namespace for monitoring. You'll see on the left things are going to start disappearing and terminating. Bye-bye, Prometheus. And then to kind of force Flux to overcome this interval, not wait for 10 minutes for this to reconcile, I would just do this manually by telling Flux to reconcile the customization that contains my monitoring stack. It's called core. I don't need to do that, actually, the source. I'll just reconcile the core. And voila, everything is back up and running. Nobody's going to notice that someone tired just obliterated an entire namespace. And that was the end of the demo. And thank you. I know I still didn't. Just a quick recap. Just a quick recap. Oh, wait. You disconnected me. I still have one more slide. Yeah. So just a quick recap of everything I just said. GitOps is basically a CD for cloud-native applications. With GitOps, you basically commit everything to your repositories, and instead of doing kubectl apply, you just do git push, and everything is deployed. And thank you. Now I'm done.
Clap louder. She deserves this. Nourhan is one of our first non-men speakers. It's very hard to find lady speakers in this in the Middle East. So my first question to Nourhan: how can we attract more female speakers?
I think like what kind of worked for me is like having a very nice support system. Basically, also like overcoming that doubt of saying like I can't do this and I'm not competent enough to do this, because I think that's a lot of self-talk that we all have, especially for females in the field, because they don't see a lot of representation. And I think just like being out there and thinking of others that you'll inspire to come also and like go out there.
So Cloud Native Computing Foundation, when they initiated the Kubernetes Community Days, they encourage first-time speakers. If you want to teach, if you want to learn basically speaking, there are meetups, there are KCDs. Just join and create a community or join a community. Any questions?
Mm-hmm.
Hello. Yeah. I had a question. So in DevOps, like there are a lot of tools available for CI/CD. Mm-hmm. Like you have GitHub Actions, you have Azure DevOps. How do you actually make a decision on which tool is right for you? You know, because there are a lot of startups, companies who hire DevOps engineers, but the DevOps, they don't know what is the right decision to make when they deploy environments, deploy applications in their production or dev environments, for let's say. Yeah.
All right, so that's actually a very good question, and I wish there was like an ideal solution to that, because it's entirely dependent on like the scale of your company, the scale of the application, what tools you have available, which cloud provider you're using. So it really depends on that like use case, and you kind of try to find the closest thing to your application requirements and your delivery requirements, and try to match that with the tools at hand. And you also, something you need to keep in mind is what stack are your team comfortable with? So for example, if everyone's used to using, for example, Microsoft Azure, then go ahead for that, because there's going to be less friction in onboarding new team members. So there is no, I really hope there was a single solution for everything, but there's not. And that's kind of also a good thing, because you end up with a bunch of tools that do different things, and depending on what you're looking for, you're definitely going to find something in the landscape.
Thank you.
If you ask me which GitOps tool to use, and you give me X versus Y, my answer will be yes. Just choose a tool and you can pivot later. But as Nourhan said, check your teams, what they are comfortable with first. Any questions? Okay. Thank you, Nourhan.
Thank you.
I think you